welcome to your next GeogPod, and this one, as you can see on screen, is about using graphs and figures and pictures in your geography GCSE exams. So the aim of this session is to basically develop your use of those graphs, figures, maps and pictures in your exams so that you can benefit the most out of those exam questions that you will be asked to answer. So you can see on screen now some of the types of things we're talking about in using these in your exams. So you might be given bar graphs, population pyramids, you might be given line graphs, pie charts, a choropleth map. You might also be given an image. And what you have to do with these is obviously use them to answer the questions that you are asked. The most important thing to remember about all of these is that this is an absolute must key skill in geography. So in almost every single topic of the GCSE papers, you will be asked to use a graph or an image or a map to answer questions. So it's something you must know how to do. You also need to know how to act when you're given that and to use that piece of information wisely to show your understanding of the figure or graph or map or picture. Remember that this is there to help you, okay? So they give you this graph, map, or image or figure to help you. It will have to be used in the answer to gain full marks in that answer. Please don't ignore it. And finally, why is this really useful and important? Because all of the little graphs, maps, images, and figures you are given to use throughout your entire topics are also very applicable to the geographical exploration paper, which is paper 3 of your GCSE, because that paper, as Mr. Rowell showed you in his GeogPod on the paper 3 masterclass, go and check it out if you haven't. These are what you will be expected to use in paper 3. You'll be given a booklet of graphs, images, and pictures, and you will have to use them and answer based on them. So it's a really important skill that you need to know for the future. So what we're going to do is I'm going to show you one reminder of a technique that you must be able to use, and then we're going to run through some exam questions and show you how they are used in practice. So the T approach, or P, as you might have been taught it, is great for using maps and graphs when you're asked to describe the pattern or describe the trend shown. So TEA or PEA, depending on if you've used the word pattern, is what you will have been taught. T or P means trends or patterns. So that means what's overall happening. So if we take this line graph on the bottom left here, we can see that overall it's rising. Okay, so it's rising overall. That's the trend. Evidence, using data and figures. So we can see that particularly from this point, let's call that 1999. From 1999, the line graph shows that the data rose exponentially. And what that means is it rose a lot more than in previous years. And then any anomaly. So on this line graph again, I can see an anomaly here, and that is that between these 2 points is the only time in which the line fell. So the data went downward. That is an anomaly. It doesn't fit the general pattern. Okay, so that is a key skill to remember to use. So let's go through some exam questions and some examples of using different figures, maps, images, and data. First one is from Global Hazards, and it's particularly from the Weather Hazards Unit. And this was a question in 2018. And it gave you this figure, and it was a map showing tropical storm tracks in North America. And it asked you to use figure 1 to describe the regional distribution of tropical storms. And that's worth 2 marks. So you're given this map. All of these colored lines have a key up here. So the yellow ones are category 1 hurricanes, and they're really weak. The purplish and pinkish ones are category 4 and 5, so they're much stronger. And then we've also got some green lines, and they're tropical storms. And then we've got some grey ones, which are very difficult to see on this map, and because there aren't many of them at all, and they're just subtropical storms, so they're not as strong. Now, First of all, let's think about what this map actually tells us. Because we're asked to describe, we don't need to worry about knowledge here. We need to just use this map. So on screen now is what this map tells me without any other knowledge. We can see that all of the storms are moving northward. Okay, so follow my mouse. They are moving northward. All right, from the tropical regions. We can also see that the most severe ones, which are categories 3 to 5, the red, purple, and pink ones, these ones here, they are on the east coast of the USA and on the southwest coast as well. Okay, but mainly the east coast of the USA. Storms are much weaker, category 1s, inland. You can see here all of the east of the USA, which is in North America. You mainly get green lines. Those green lines are the weaker storms, and they are mainly the tropical storms. Okay, and you also have yellow ones along the coast, and they are the weak ones too, in category 1. And finally, we can also see that it's only the eastern and southern parts of America that are actually impacted by these storms. The rest of the USA is largely not impacted, particularly the north and west. So that's everything that this map has told us. There's no knowledge there that I have gained apart from this map. So what do you then do for your answer? Well, we know it's 2 marks, so we need to make 2 significant points. So on screen now, there are 2 long sentences that make 2 significant points. So I've said that most category 4 or 5 storms, and they are purple and pink, hit the east and southeast coast, where my mouse is now, of the USA. For example, Florida. Now, Florida is this tip down here, and the reason I've named Florida is because the question asked for regional patterns, and that's part of the region. And storms are weaker inland, so they're weaker in the north and west and in central USA. The further south in North America, the greater the category of storm. In other words, from the north, the category of storm is relatively weak. The further south we go, the stronger the storms get. So that is a sample answer for this question. I have just used what I see on the map. The figure here has been really useful to me in answering this question. If I didn't use the figure, I would have to make it up essentially. Okay, so that is why figures and maps are really useful. The second question we're going to go through shows you in the resource booklet, you've got a map showing the global distribution of ecosystems. So this is a map showing all of the ecosystems of the world, and you've got a key at the bottom to tell you what color is what ecosystem. And the question is, using figure 4, describe the global distribution of temperate deciduous forest ecosystems. So again, that word describe comes up. We don't need to know anything, we just need to use the map. And distribution, again, we can apply our PEA or TEA to this question. So we're looking at the temperate deciduous forest. That is this mild coloured green. It's the middle colour green. And you can see, if we look at the map straight away, all of the UK and Ireland, all of Europe, practically, particularly the northern half, the east coast of China, the southeast coast of Australia, and the east coast of North America. All of those areas are this colour. So all of those areas are temperate deciduous forest. We're asked to describe where they are in the world, describe the global distribution. So the map has told me this. Most deciduous forest ecosystems are in the northern hemisphere, above the equator. Okay, now notice I use the word most. I haven't said all, I've just said most. This is north of the Tropic of Cancer. Now, you might be thinking, why have I picked that out? Because if we're given a map with lines of latitude, like Tropic of Cancer, Equator, and Tropic of Capricorn on, we are going to use them. All right, they're given to us for a reason, so use them. Most of Europe is classified as deciduous forest, as we said earlier, like the UK. And an outlier, or an anomaly, is Southeast Australia, which is down here. And the reason for that is because it's south of the equator. It's the only area on this map, south of the equator, that is temperate deciduous forest. So I have again got all this information from this map. I've used the map really well because I know where the Tropic of Cancer is. I've mentioned the UK, I've picked out Europe, and I've picked out Australia. So we need to try and construct an answer now for 2 marks that describes that global distribution overall of those forest ecosystems. So here is a sample answer. Most deciduous forest ecosystems are north of the Tropic of Cancer in the northern hemisphere. That would be 1 mark straight away. That's absolutely correct. That's where most of them are. Europe, for example, the UK, is all deciduous forest. That would be your 2nd mark, 2 marks in total. But I've put 1 final point in there in case this was 3 marks, because it could be. And I've said Southeast Australia is an anomaly. So that is the TEA approach, remember? And I've included the A even though you don't really need it for 2 marks. So that is how you would use that type of map to answer that type of question on describe the distribution. Now then, I'm going to give you 10 seconds here to have a read of what's just put on screen, okay? Please make sure you have a read of the little questions there and have a look at the map you're given. Okay, so we are given figure 1, which shows predicted population growth for the world's top 15 megacities. So the top 15 megacities in terms of population are on the map, and we're given a number of short 1 mark answered questions. So each of these are worth 1 mark, as you can see here. The first question, state the population of New Delhi for 2011. Now, when something says state, we just have to say what it is. We don't have to explain anything. So what is the population of New Delhi for 2011? First of all, we have to find New Delhi. So I'm going to circle that for you now. So we can see New Delhi is here. And in red is today's population, as the key says, in 2011. And in black is the population and what it's expected to be in 2025. So we were asked for today's population of New Delhi in 2011. That is 23 million. So we write 23 million down. Please remember to write the word million. If you just write 23, that is not correct. Okay, so that would be 23 people. Make sure you write the word million, otherwise you will not get the mark. Next, by how much is the population of Beijing predicted to grow in millions by 2025? So let's pick out Beijing now. And that's on the very, very east side of this map. You can see it here. And we're asked to calculate basically how much it's going to grow by. So it's 16 million in 2011, and it's projected to be 23 million in 2025. So what's that difference there? From 16 million to 23 million. You can do a quick sum if you want to, or you can work it out in your head. You do not have to show any workings out for these answers because you're not given the space to. All right. So how do we work that out? 23 minus 16, and that gives us 7. So the difference it's expected to grow by is 7 million. Again, write the word million, please, not 7. The third question, part 3, is slightly harder. This involves some mathematical skill. Calculate the percentage increase in population for Shanghai. So again, I go back to my resource. Find Shanghai. I've circled it for you now. We know that Shanghai in 2011 had a population of 20 million, and it is projected to rise to 28 million by 2025. But we're not given the percentage increase for this one, so we have to calculate that. Some of you in your head will be able to work out what the percentage increase is from 20 to 28. Others of you might not know how. So this is what you do on a calculator, because you should always have a calculator in your geography GCSE exam. You would look for the 8 million increase. Okay, so we know that it's gone from 20 to 28, so that's an 8 million increase. So what we do is we take that 8 million increase, divide it into 20 million, and multiply it by 100, and you will find that the total population increase, if we add 8 million to 20 in percentage, is 40%. Now again, you don't have to show any of the working out. The answer you have to give is 40%. So you just calculate that on your calculator based on the figures that the graph gave you, or the map, sorry, gave you, and then you write the answer down. And then there was a final other question on this map. And it said, in which continent are most of the megacities on figure 1 located? So what continent has most of the megacities on this map? Here you need to know your basic geography, okay? So you need to know the continents. Now you can rule the wrong answers out, okay? So we know that it's not, for example, Europe, because Europe has no megacities on this map. So we know it can't be that. We know that it's not North America because there's only 3 there. And we know that it's not South America because there's only 3 there. So the only answer it can be is Asia. And we can see in Asia there are more than 5. So that has to be the correct answer. So A for Asia. And that's it. So that is how you use a map with 4 simple questions here, 4 marks, nice easy 4 marks using this figure. And that's it. So the next question on screen for you shows you figure 2. And figure 2 is a map of North and South America. And it gives you the IMF, the country classifications by the International Monetary Fund in terms of development. And it says, using figure 2, describe the pattern of development by country classifications. So again, describe the pattern. Okay, we've said this before. Use TEA. And this one's worth 3 marks. So we've got to have a trend. We've got to have an example. And we've got to have an anomaly here to get 3 marks. You can see there's a key for this figure. The grey ones are advanced countries like the UK. So they are rich. The emerging developing countries, so the EDCs, they are yellow. And we can see that the low income ones, the poorest of the nations, are in purple. So what does the map tell us? There's a clear divide here between North and South. So North America, which includes the USA, Canada, Alaska, Greenland, etc., that all is grey, which means it's all advanced countries. Whereas South America, which is Mexico southward, and that includes Bolivia and it includes Brazil and Chile and so on, they are all either yellow or purple. So they are all EDCs or LIDCs. Then I can spot that the USA and Canada are ACs, Brazil and Chile are EDCs, and Bolivia, which is this one here, is an LIDC. And then I might want to pick out some anomalies. So I've said that in North America, we could say that Mexico is an anomaly. And I've also said that in South America, we could say that Bolivia is an anomaly because the rest of the countries that surround it are EDCs, not LIDCs. So that's what the map has told me. Now here's the answer. Remember, 3 marks of TEA or PEA. The pattern here, so that's your P, is that the northern regions in North America, which include the USA and Canada, are developed ACs, and South America are EDCs, which are less developed. Bolivia is one of the anomalies in South America as it's an LIDC, so that's there. And Mexico is an anomaly in North America as it's only an EDC. Okay, so hopefully that helps you with also using a map like this and picking out the patterns you see overall. The next type of question I have for you is a different type of question. This was in 2018 as well, and you were given this graph exactly as you see it. It said use the data to complete the divided bar for 1911, and it was 1 mark. So we can see what colors are used for what ages. So what we're going to try and do with our pencil is shade it in as well so that we can see which sections are which. We can see that they've started with the 0 to 14 range at the bottom, so we're going to do the same. So what we're going to do is we're going to look at the 0 to 14 range, and the data we've been given says it should be 30%. We've got the percentages on the left-hand side. Most of you will know how to do this without me telling you how to do it. However, what's really key here is accuracy. You must be extremely accurate. If you are not, you will not get the mark, even if it's only slight. So I'm now going to add on my 30% for 0 to 14. And as you can see there, I've gone right up to the 30% mark and I've drawn my line and shaded it in. Next, I need to add 65% for 14 to 64. And we can see that that category is very light grey. So what we're going to do is, and this is the tricky bit, we need to add on 65%. So from 30 to add on 65%, all we do is 65 plus 30, and that gets to 95. So then we get our pencil again, we go up to 95, we draw a line, and we shade it in light grey. And finally then, the remaining bit, and you can check your work here, the remaining bit has to be 5%. Is that 5%? 95 to 100? Yes, it is. So we shade that in the medium coloured grey. That then is your completed bar graph. You got 1 mark for doing that. So drawing 3 lines and shading them in, you got 1 mark for doing that. There is also then a question though based on this set of bar graphs as well. So you've got to use the figure again. Okay, and that says which of the following statements correctly describes a change shown in the graph above. So which of these statements is true? The percentage of population aged 0 to 14 increases. So let's have a look. Here it is here. So the dark grey. Does it increase or decrease? Well, we know, we can see there that it's getting smaller. So actually it decreases. So that can't be right. The percentage of population aged between 15 to 64 increases. Well, if you have a look, as the light grey ones here, it actually stays the same mostly. It doesn't really change. So let's check again. The percentage of population aged over 65 increases. Let's have a look here. So that's this top one. So it's 5% in 1911. It's then around 16% in 2001. And then it's around 17% in 2011. So that has to be right then. So that is the category that's increasing. So C is the correct answer. Okay, so can you see how you need to be able to do the first part correctly to answer the second part here? You've got to be able to fill in this bar graph correctly, okay? So let's move on to our next one. This one says using data from the graph, describe the trend shown. So again, you're given a graph here. I'm going to give you 10 seconds again this time to look at this graph and think about describing that trend. What would you pick out? So again, it's 3 marks. So you've got to be able to pick out 3 things using TEA. Okay, so I'm going to put on screen what I've picked out. All right, so this is a simple line temperature graph showing you the changes from 400,000 years ago to today, or 1950. I've picked out the following. The temperature fluctuates over the last 400,000 years. That word fluctuates is massively important. That basically helps you say it changes all the time. And we know that from this graph, we can see it changes all the time. Okay, so the temperature fluctuates. The highest temperatures were 325,000 and 125,000 years ago. Let's find them. So 325,000 is here. And 125,000 is here. They're the 2 highest temperatures we've got on this graph. Okay, and I've said that they had a 3 degrees Celsius increase. So if we have a look at our degrees Celsius on the left, sorry, we can see that they're both at 3 degrees Celsius increase. The pattern repeats itself every 100,000 years. Okay, so what I've said is roughly every 100,000 years, take this point to this point. What we see is the same trend. So it goes really high and then it falls down towards -8. And it goes really high again, it falls down towards -8. Then it goes really high again and falls down towards -8. So what we're seeing is every 100,000 years, the same thing happens. The lowest temperatures on the graph are -8. That's what I've picked out here as well, or just above it. And the present day temperature today, 1950, we can see that the line is going up and down and up and down and up and down. It's fluctuating around 0. So as you can see, again, I have just picked out what I can see in the graph. I do not know anything before going into the exam about this graph. I am just reading what I see. Now we have to actually answer the question, don't we? PEA or TEA, trend, example, anomaly for 3 marks. So on screen now, you've got an answer that shows you how I have used the information I've gained from the graph. So let me read through it. Overall, global temperatures have fluctuated over the past 400,000 years. Again, that word fluctuated. Tick, 1 mark. The highest temperatures were 325 and 125,000 years ago at 3 degrees Celsius. Okay, so I picked out the highest point. Every 100,000 years, the pattern appears to repeat itself. So I get my second mark there for saying the highest temperatures and the pattern again. Finally, an anomaly to this pattern is present day, 1950. So I've picked out present day as an anomaly, where temperatures appear to be remaining above and below zero for a longer time period. So if you look at today, where my mouse is now, it appears that the line is showing us temperatures are staying around zero for quite a while, compared to, if we look back along that line, the last 400,000 years, where the temperature didn't really stay there at all. So what we're seeing is warming in the atmosphere, okay? And therefore, that is an anomaly compared to the last 400,000 years. So what I've done again is TEA, 3 sentences, trend, example from the graph, anomaly, and I get my 3 marks. And finally, I want to say, again, I knew nothing before this graph. I've just picked all this information out from looking at the graph. So that is why graphs, figures, images, and maps are useful to you. They have all the answers on them. The next type of question is a bit different. So this time they give you figure 2 on the bottom right here, and it's an image of the River Thames, okay, in 1667. And we're told that it's frozen, and we can see that here. We can see the icebergs in the River Thames. We can see it's frozen over. We're asked this time to explain, not describe, explain how this painting could be used as evidence for climate change. So how is this painting useful to us as evidence for climate change? What does it tell us about climate change? So what can I see in the painting? Well, I can see that the River Thames was frozen in this painting in 1677, but we know that the River Thames is not frozen today. So we know it's warmer today than it was in this painting. So the climate today is warmer than what's shown in 1677. And the painting also shows, therefore, that it was very cold in 1677, which is what caused the River Thames to freeze. So back to the question, explain how this painting could be used as evidence for climate change. Well, here's the answer. Nice and short for 2 marks. Figure 2 shows the River Thames frozen over. This does not happen today. 1 mark. Temperatures in 1677 were very cold, but today is much warmer, and that means climate change has happened. 2nd mark. So this answer is much simpler than you might think it is. Essentially, what you're saying is the picture shows that it was much colder back in 1677 than it is today, because the River Thames is frozen over in the picture, and today it's not. That's it. So again, all of your answers really are in this picture. You've just got to explain them. Okay? Right, this is the final question I'm going to do with you. And hopefully that will have given you enough ways in which you can use graphs, maps, images, etc. to answer your question. This one's a 4-mark question, so it's a bit longer. But again, all of the answers really are in these graphs. You just have to use them well. So it says, study figure 4, a map which shows household forecast for using water in England and Wales. So that is figure 4 at the bottom here. We can see it's got a key. The darker the colour, the more use of water. The lighter the colour, the less use of water. Why will the southeast of England be an area of severe water stress in the future? Why will the southeast of England, where my mouse is now, be an area that will suffer from water stress, in other words, a potential lack of water in future? Use evidence from figure 3 and figure 4 to explain your answer. Now, figure 3 is really helpful because it actually tells us the average rainfall each year in the UK. And the brown colours are very low amounts of rainfall with the key. And the blue colours and white colours are higher amounts of rainfall. So what we need to do is compare the two maps. So we know that in the west on this rainfall map, there is much more rainfall, okay? The blue colours. Let's have a look at our household use map. In the west, yes, there are some higher uses of water, but actually overall, they're quite low. They're between 130 and 150 on the key. So actually, in the west, we've got high amounts of rainfall, but relatively moderate uses of water. So that's a good thing. We're actually using less in the west than we are getting from rainfall. Now let's look at the east and the south. We can see very clearly that the southeast, okay, we can see very clearly all of here is getting minimal rainfall. So it's only getting either less than 600 or up to 800 millimeters of rainfall a year. That's not a lot at all. However, if we look at our usage map, we can see that the southeast of the UK is the part of the UK that has the highest amount of household use of water each year. Okay, so that's a big problem. The southeast gets the least amount of rainfall and the least amount of water supply, but it has the most amount of usage. So there is the problem. The southeast of England will have the most amount of usage in future with the least amount of supply, the least amount of rainfall to supply it. So the map has told us lots of key things there, and we've got the key to be able to use in our answer. So let's look at what the map told us. And as I said before, figure 3 shows the west receives the most rainfall, and Scotland even reaches over 3,000 millimeters in some places, whereas the east receives much less at around 600 millimeters a year in some places. Figure 4 also shows that the least amount of rainfall is in the south, but the average household usage of water every year is the highest at 170 plus. So how do we use this for our answer? So here you go. This is an answer for this question. 4 marks, remember. So we've got to explain it a bit. The southeast of England receives the lowest amount of rainfall in the UK. Straight away, tick, 1 mark. That's one of the reasons why southeast of England will suffer from water stress. Some parts of the southeast receive less than 600 millimeters per year. Again, use the figure. I can see very clearly that some parts of the southeast here are dark brown. They receive less than 600 millimeters of rainfall a year, so I've said that. However, the southeast also has the highest average household use of water per day. So the southeast uses the most water at 170 litres plus. So that's a contradiction. Basically what we're saying here is, even though it receives the least amount of rainfall, it uses the most of water per year. This means, and this is my explanation, this means that the southeast does not receive enough water supply to keep up with household use. Therefore, the southeast will be in severe water stress in future. 4 marks, done. I have used the figure really well to explain and show, using the numbers on the figure and the map, that the southeast uses the most amount of water but receives the least amount of rainfall. So that concludes this quick session looking at how we use maps, images, figures, and graphs in our answers, making sure the key thing is that we absolutely quote from the figures. So key points: use TEA for all graphs and maps to describe them. Say what you see when you're asked to describe. That helps you understand it. Use evidence from the resource. Quote numbers, quote statistics, quote a date, name the figure, calculate something, refer to it in some way. The resource is there to help you, so let it help you. Use it. And finally, the best way to get this into your brain is to practice it again, and practice it again. Practice, practice, practice. You could even practice these questions on this GeogPod to help you out and see how I have used them. So that is all. Hopefully you found this useful. Please do take a look at Mr. L's Paper 3 Masterclass GeogPod, where he also talks you through Paper 3, because that paper will have lots of graphs, images, maps, etc. in them. So you will have to be able to use them there as well. Please do check out our other GeogPods on the YouTube channel, on the Google Doc that you've got. You've got all the links there. You've got all the names of the YouTube videos. Please use them. They are there for your use. And I will see you in the next GeogPod.